Now, another transformation that can happen along sine and cosine functions is known as the phase shift. Now, what a phase shift is it's the difference between some horizontal position among our graphs and where it should be on the parent function. So, for example, say on my sine graph, this value right here is where it normally is on my sine function. And instead, it's moved over to this point. That point it's moved over is known as the phase shift. And the way we find phase shift is using this equation right here. Negative fraction c over absolute value of b. So if we know c and we know b, we can figure out what our phase shift is, the amount that it moves over. Let's look at an equation or a problem. It says state the amplitude, period, frequency, and phase shift of this equation right here. Y equals sine of 3x minus pi over 2. Then graph two periods of the function. Okay, so if we're looking at our equation right here, our amplitude is a, the number in front of our sine or cosine function. So in this one, my amplitude is going to be what? Well, there's nothing there in front of sine, so our amplitude is going to be 1. If there's nothing in front of it, it's just a 1. Next, we have to find the period. The period, remember, is 2 pi over the absolute value of b. So in ours, b is 3. So we do 2 pi over 3 is our period. Then we're looking for the frequency. Frequency was 1 over the period, which in our case was 2 pi over 3. Reduce that out anytime you divide by a fraction, you multiply by the reciprocal. So my frequency is 3 over 2 pi. And finally, we need to find the phase shift. So to find the phase shift, remember that was negative c over the absolute value of b. So in our case, it was negative c is negative pi over 2. If you're wondering how I get negative pi over 2, remember it's minus, so that's like a negative. Normally it's plus c. Okay, all over the absolute value of 3. So to simplify it, minus makes a positive, and pi over 2 times 3 would be 6. So my phase shift is pi over 6. That's how much I move from one horizontal location to the other. So now it's asking us to graph two periods of the function. So we need to make a table of values. Okay? So, a couple things we need to take into consideration. First, we need to take in the period, and we need to take in the phase shift. So if we look back earlier, our period is 2 pi over 3. It means that from 0 to 2 pi over 3, I need to go from 0 to 0 again. So first, I'm going to find the midpoint in between those two. That would be pi over 3. And so that again has to be 0. And now to find my other values, I'm going to find the midpoint of each one there. So midpoint between 0 and pi over 3 would be pi over 6. And that's going to be 1, because a normal sine graph goes from 0 to 1. It's not negative, so we know it doesn't switch orders. It's not a reflection. And then the halfway point between pi over 3 and 2 pi over 3 would be pi over 2. And then that y value is negative 1. So now I have that. Now, the difference is this is just when we're looking at the difference in the period. Now we have to take into consideration the phase shift. So this is actually the equation, f of x equals sine of 3x minus pi over 2. Now we said our phase shift is pi over 6. So that means I'm going to add pi over 6 to every one of my x values to start. So 0 plus pi over 6 is just going to be pi over 6. Then it'll be pi over 3, pi over 2, 2 pi over 3, and then 5 pi over 6. And then my y values, since I already took into consideration my phase shift, are just going to stay the same. Alright, so now that we have our table of values, we can actually make our graph. So, highest it ever goes is 1, lowest it ever goes is -1, okay? And so let's take into consideration all of our values. So this could be pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and then we go to pi. Alright? So put in our values. Okay? So pi over 6 is 0. Pi over 3 is 1. Pi over 2 is 0. 2 pi over 3 is -1. Pi over 6 is 0. And then it just would repeat itself, so go back up to 1. I can also go backwards. So since pi over 6 is 0, 0 is going to be -1. And so you'll see that my sine graph now looks like this. And so on and so forth. Now the very last translation of a sine or cosine function is this part right here, -1. What it does is it moves our graph up or down, and that midline, which is normally 0 for sine, now becomes a different value. So if we look at this one right here, let's answer the questions they're asking first. Amplitude. Amplitude is the number in front of my sine or cosine. This one is 1. Then we need to find period. Remember, period is 2 pi over the absolute value of b. So in ours, 2 pi over absolute value of 1, because there's just nothing in front of x. So that means that my period is 2 pi, like a normal sine graph. Our frequency is 1 over my period. So it'd be 1 over 2 pi. My phase shift remember, is -c over absolute value of b. So in our case, it would be negative. C is 2 pi over absolute value of b, which is 1. So then my phase shift is just minus 2 pi, which is nice because that's one period, so it doesn't really affect the look of our graph much. And then the last thing they ask us to find is the vertical shift. So the vertical shift then is -1, which means my whole midline, instead of starting at 0 and going up and down from there, starts at -1 and goes up to 0, back to -1, down to -2, and so on and so forth. So what we can do is we can graph. Now the nice thing is that when we make our x and y table, vertical shift is -2 pi. So I go -2 pi, okay, starting at 0. Then I would add pi over 2, so that would be -3 pi over 2. Okay, add another pi over 2 would be -pi. Add another pi over 2 would be -pi over 2, and then I'd go to 0. And our y's, now this is where it changes just a little bit. Okay? Now normally at 0, or our phase shifted to 2 pi, it would be 0. But since my vertical shift is down 1, I'm going to subtract 1 from that value. So it's going to be negative 1. Then pi over 3 goes up to 0. Then negative 1. Then negative pi over 2 would be negative 2. And then back up to negative 1. Alright, so you'll see there's a little bit of a difference. And now I'll graph. Okay. Let's start that value right there as negative 2 pi, negative 3 pi over 2, negative pi, negative pi over 2, then to 0. Then we have pi over 2, pi, 3 pi over 2, 2 pi. Alright? So this would be negative 1, and then down here would be negative 2, 0, and positive 1. Now we just graph the values that we found. So at negative 2 we're at negative 1, 3 over 2 we're at 0, at negative pi we're at negative 1, at negative pi over 2 we're at negative 2, and then at 0 we're back to negative 1. Then we can repeat. Pi over 2 is at 0, negative 1, negative 2, and 1. So you'll see it still looks like a sine function. The only difference is it's shifted vertically down one value. So instead of going through x equals 0, it goes through this line right here, x equals negative 1. That's what it goes through. Alright, so here's some information. We've already looked at all this. It's all in your notes, and so we can use this information going forward.